Today's lesson is on comparing two proportions. Feel free at any point to pause, to rewind, to pause it while you write stuff down. Take this and use it so that you can go at your own pace. Suppose we want to compare the proportions of individuals with a certain characteristic in population 1 and in a separate population 2. So population or treatments, we have two separate populations. So this is not a matched pairs for a one sample. This is two completely different samples. Our parameters are going to be P sub 1, representing the first population, and P sub 2. The statistic are going to be P hat sub 1 and P hat sub 2. So you've got these sub 1, sub 2 numbers so that you can always know what population they're coming from. And the sample size is going to be little n sub 1 and n sub 2. We compare the populations or treatments by doing inferences about the difference between the parameters P1 minus P2. And again, you're always going to specify which one's which. The statistic that estimates this difference is the difference between the two sample proportions. So I don't know what the parameters are, but I want to sort of find this interval, this confidence interval, that I'm pretty sure the difference of the proportions is going to land in. But I do this with my sample data. So P hat sub 1 minus P hat sub 2. To use that for inference, we must know its sampling distribution. We've got to know the shape, center, and the spread. So the sampling distribution of P hat sub 1 minus P hat sub 2. The shape is going to be approximately normal when the large counts condition happens, but you have to test it for both samples. So you've got n sub 1 times P sub 1 has to be greater than or equal to 10. You've got to check it for sample 1, and then you also have to be able to check it for sample 2. So you have to show both. The mean of this distribution looks like this: mu sub P sub 1 hat and P hat sub 2 equals the parameter P sub 1 minus P sub 2. So the mean of the difference of the samples of proportions is equal to the difference of the parameter proportions. The spread, so that's talking about the standard deviation. So the first thing I want to point out is that your 10% condition has to be met. Well, you have to show the 10% condition for both samples. So you're going to have to do that and that. So once you show that, then your standard deviation for P hat sub 1 minus P hat sub 2 equals the square root of, and then you've got both standard deviations under the square root with a plus sign on it. And I'm pretty sure that exact formula is on the bottom back of your formula sheet. Okay, so let's actually see if we can do some stuff. So Yummy Goldfish, your teacher brings 2 bags of colored goldfish crackers to class. Bag number 1 has 25% red crackers, and bag number 2 has 35% red crackers. Okay, now stop for just a second. That's a proportion. That's not a mean. This is a proportion. But is that a sample proportion or is that a parameter proportion? Well, it's 25% of the entire bag number 1. So this is parameter. This is P with no hat. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate sample of 40 crackers from bag 2. Let P hat sub 1 minus P hat sub 2 be the difference in the sample proportions, because I now have a cup of 50 and 40 crackers from each bag. So these are samples of the red crackers. So this is the difference, and hats because these are samples. What is the shape of the sampling distribution of the differences of these sample proportions, and why? Find the mean, show your work, and find the standard deviation, show your work. Okay, so let's talk shape. So the shape is it normal? Okay, so to do that, what do I have to test? I have to test my large counts condition. Okay, so here's a question. Do these get hats or not? Well, when you go back and look at these numbers, are these proportions or are these parameters? I mean, are these, sorry, parameters or are they statistics? Well, they're parameters because they're from the entire population of that bag. So no hats. And just be real careful with your subs and your hats and your all that stuff to make sure you're good. All right, so bag number 1 had 50 goldfish in it and 25% of them were red. And so that's 12 and a half. So we're good there, just barely, but we're good. And then let's see, if that was 25%, this would be 75%. So that's 37.5, which is good. Bag number 2 had 40 in it, and it was 35% red. And that's 14. And so that's good. And this one had 40, and let's see, if that's 35, this would be 65. Sorry, ran out of room. And so that's 26. So that's good. So we have just proven that we can use a normal distribution to approximate this. So we would say the sampling distribution of p hat 1 minus p hat 2 is approximately normal. Okay, let's change colors. Mean. Well, the mean of the sampling, or the difference of the sampling distribution, is equal to the difference of the two motherships. Okay, and again, this is everything they want to see, so this is everything I want to see. I want to see all the N's and the P's and the Q's, and I want to see the mu's and the subs and the, I don't have my little numbers down here. There we go. You want to label everything, you want to show all your letters, you want to show them plugging in your numbers and show them your answer. Okay, and then the last one was the standard deviation, which is the spread. And what's the first thing you have to do before you can touch the standard deviation is to show the 10% condition. So you have to show that guy, and you have to show that guy. So this would be 50, and this would be all goldfish in bag number 1. 10%, so that would mean there'd have to be 500, and it says that they're well over 1,000, so we're good there. And then this one had 40 in it. All goldfish in bag number 2, and again it said it had well over 1,000, and this would mean only need to be 400, so we're good there too. So now that we've done that, we can actually find the standard deviation of the difference of the sampling proportions. Okay, and if we use that formula, which we're going to show, Q1 over N1, 2, Q2. Okay. And then we're going to shove numbers in here, 0.25, 0.75, and that bag was 50. And this one's 0.35 and 0.65, and he's over 40. Now, I strongly recommend that you pause it right here and you plug that into your calculator, making sure you know how to type it in. The answer is 0.0971. Notice I went 3 decimal places because I don't like 0 to start it off. So I highly recommend you pause it right here, punch that in, make sure you're solid with that on your calculator, and then just hit play when you're good. Okay, so we are going to find a confidence interval for P sub 1 minus P sub 2. So this is the difference of the population parameter proportions. A confidence interval. We're not doing a test. We're going back to chapter 8 and we're doing a confidence interval. So this is sort of like the how big is the dartboard. So I don't know. I'm not going to know what P1 and P2 are, but I'm going to find a confidence interval for their difference using the sampling information. So the title of what you're doing is a 2 sample, not 1 sample, Z interval, Z because we're doing what? Proportions, for the difference between 2 proportions. So 2 sample, Z interval, difference between 2 proportions. And that's got to be there. That's got to be at the top of your paper. Conditions, we have to be random, and it should just flat out say that for both samples, it should be random. Independent, you've got to do your 10% condition for both sample sizes. And my large counts conditions, you've got all 4. Now notice on this one, I have hats. So why do I have hats on this stuff? Well, that's because I don't know this information, because I'm finding a confidence interval for them. So I'm sort of giving you a window of where I think they're going to fall, but the data that I'm going to have is actually sample data. So that's why these have hats on them. Okay, and that's basically what this is. So this formula is is what you're going to see on your formula sheet, but we are changing it to this because we don't have population information. We have sample proportions. So we're going to call this the standard error or the estimated standard deviation because we're doing the best we can because we don't know what P and Q are. Okay, and then these guys, which we love, so that's our dear old formula at the top of the back of our formula sheet. So our statistic is the difference between the two, plus or minus. Our critical value is Z star, because I'm going to give you like a 95% confidence interval, so that's a critical Z, and a Z, not a T, a Z because we're doing proportions. And then you've got your standard deviation of statistics, and again, make sure you have hats on them. Okay, so here we go. All that's left is for us to walk through 2 examples from start to finish. And again, please feel free to pause it whenever you need to, or rewind it and go back through it again, or do whatever it is you need to do. Okay, here we go. Teens and adults on social networking sites. As part of the Pew Internet and American Life project, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. The second survey posed a similar question to a random sample of 2,253 U.S. adults. In these 2 studies, 80% of the teens and 69% of the adults used social networking sites. Calculate the standard error of the sampling distribution of the difference in the sample proportions, and they're telling us how they want it set up. They want teens minus adults. What information does this value provide? Construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. So this little piece right here is really a step that we would do anyway. Maybe not, we wouldn't answer this sentence outright, but this is just telling us to find the standard deviation, which we would do anyway. Okay, here we go. To answer the very first question, our standard error of P hat sub 1 minus p hat sub 2. And we're going to define all our variables. Don't worry about it. And so this is p hat sub 1. Nope, not p. Q. And then I'm going to put my numbers in here. So from sample 1, which was the teenagers, that was 80. So this is going to be 20. And there were 799 of them. For the adults, it was 69. So this is going to be 31. And there was 2253 of them. Plug that into your calculators. And there's my standard deviation. Again, I went 4 decimal places because it starts with a 0. So feel free to type that in and make sure you get that right. Okay, then it says, what information does this value provide? Okay, I'm going to read it first and then I'm going to write it. Okay, so here's what it provides. If we took many samples of 799 teens and 2,253 adults, the difference in the sample proportions of teens and adults who use social networking sites will typically be 0.0172 from the true difference of these proportions. All right, here we go. If we took many samples of 799 teens and 2,253 adults, the difference in the sample proportions of teens and adults, and then you got to say what they're doing, who use social networking sites will typically, remember that word, be 0.0172 from the true difference of these proportions. If we took many samples of teens and adults, the difference in the sampling proportions of teens and adults who use social networking sites will typically be that much off from the true difference of these proportions. So the important word, true, typically, make sure you put that you're doing the difference, and make sure you state what they're doing. I mean, I could underline the whole thing, but those are the snippets that really stick out. Okay, so that just sort of gets that question out of the way. Okay, so now, if we were going to start this problem from scratch, if we were going to say, construct and interpret a 95% confidence interval for the difference of proportions of all U.S. teens and adults, and we're doing teens minus adults. Okay, so first of all, what are we? We are a 2-sample Z interval, not test. Make sure you have that straight. I'm not doing a test. I don't have an H sub O and an H sub A. I'm not going to accept or reject. I'm finding a confidence interval. So a 2-sample Z interval for the difference between 2 proportions. Okay. Now let's define our variables. And specifically, we're defining our parameters. So P sub 1, now if this is a parameter, how do you start that? It is the true proportion of all U.S. teens who use social networking sites. So P sub 2 is the true proportion of all U.S. adults who use social networking sites. Okay, so I've done the first two things that we always, not always, but that we could potentially forget. So we have defined what it is that we're doing, and we have defined our parameters. So next thing, I think we should check our conditions. Okay, so first one, random. Let's go back and read. Random sample, random sample. So we are good. Okay. The next one, independent. Okay. To test if we're independent, I need to do the 10% condition, but I need to do it for both sample sizes. So this is 799, all U.S. teens. Not all U.S. teens who use networking sites. That's your top number of your proportion. This is the bottom number. This is out of all U.S. teens. So that would mean that there would need to be 7,990 U.S. teens, and yep, I think we're good there. Adults, there were 2,253, all U.S. adults. And that would mean there'd need to be 22,530, and I think we're good there for the United States. The last condition is the large counts condition, and this one gets a little bit more involved because we have two samples. Just watch your sub numbers and whether you need hats or not. So do you need hats for this? Well, think about what your data is. These proportions that we're going to come up with, the 69% and the 80%, is that a proportion or is that a sample? That's from a sample. So then these have to have hats on them. So just make sure it makes sense. So N sub 1, P hat sub 1 has to be greater than or equal to 10. And N sub 1, Q hat sub 1 has to be greater than or equal to 10. And then N sub 2, P hat sub 2, and N sub 2, Q hat sub 2. And then we put numbers in here. And let's see, that was 80%. And that turns out to be 639.2, which is definitely bigger than 10. And 799 times 20%, and that's 159.8. Make sure when you're doing this, some of you are getting real sloppy in here and just sort of flying through this. Make sure that it's crisp and clear and can be read. So, you know, just slow down and do it right. 2253.69, and that's 15546, which is definitely bigger than 10. And this one's 2253 times 31%, and that's 698.4, which again, definitely bigger than 10. Okay, so we've done all the pre stuff. Now we get to get down and dirty with the good stuff. Okay, and again, remember you are finding an interval. So where do you start? You start with your words. Statistic, plus or minus, critical value, times standard deviation. Okay, now you go letters. Statistic, be careful here. This is, and I've already defined who P1 is and P2 is, so I know that this is teens minus adults. Z's because we are, and it's a Z star, so it's a critical value, and a Z's because we are proportions. And these have hats on them because I don't know my population data. And then I plug numbers in. Okay, then I got to come over here and find my critical value because I need my Z. So we're 95%. So I'm 2.5% here, and I want to know where to cut it off. So that's inverse norm. 0.02501 plus or minus 1.96, and I don't have my Z star equals that. So plus or minus 1.96, and then that guy we found way back up here, but normally you're not going to have already found that step, so you're going to take this piece right here and write it down there, but since we already know what the number is, I'm just going to write the number. But again, remember, normally you don't do that step ahead of time. This is just having to ask us for it. So then this is, what was it, 0.0172. Okay, and then you type. And I want you to practice typing, and I would always do the -1 first, because when you do your interval, it just helps you get your lower number first. I got 0.0763 and 0.144. So again, pause, do both of these, and make sure you can find your interval, and then just hit play when you're good. Okay, so now we just need to make our conclusion. Okay, so I'm going to read it first, and then we'll write it. We are 95% confident that our interval 0.0763 to 0.144 captures the true difference, in parentheses, I'm going to write teen minus adults, in the proportion of all U.S. teens and adults who use social networking sites. We are 95% confident that our interval, and this is a proportion, so it's not a measurement of anything, so you don't need to put people, because these aren't people. Again, this is a proportion. Captures the true difference, and because I'm writing the word difference here, I'm just going to go in parentheses, teens minus adults. The true difference in the proportion, because you can't say the true difference of all teens and adults who use social networking sites, because these aren't numbers of people. This is the proportion of the number of people. So in the proportion of all U.S. teens and adults who use social networking sites. All right, ta-da, there's our problem start to finish. Might not be a bad idea to rewind, and we got one more to do, but to rewind to this one and go back and just listen to it without having to write anything down, and just hear it, just like you were sitting in class listening to me teach it. Okay, we got one more to do. Are teens or adults more likely to go online daily? The Pew Internet and American Life Project asked a random sample of 799 teens, and a separate sample of 2253 adults how often they use the internet. In these two surveys, 63% of the teens and 68% of the adults say they go online every day. Construct a 90% confidence interval for the difference of proportions. Okay, so first things first, what are we? We are a two sample Z interval, not test, for difference of proportions. Now, did they say which minus which? They didn't specifically say that. So over here, I'm just going to go teens minus adults, just to sort of state it out there in the open. The next things I need to do are define my parameters, and I have two of them because I have two samples, and these are parameters so they don't get hats. The true proportion of all teens who go on the internet every day. And this one is the same thing, but it's adults. Did I miss the word US? It doesn't say US, does it? Okay, so we're just going to go with, it does say American Life Project, but it doesn't specifically say US, so I'm just going to say teens and adults. Okay, I'm going to check my conditions. Random. If you go back up there and look, it says random sample for both of them. Independent. I've checked my 10% condition. And again, I'm just cruising through this. If you need to pause and catch up or whatever you want to do, feel free so that you go at your pace. And I'm just going to put all teens here. I'm not going to put US because it doesn't specifically say, and I don't want to assume anything. And the large counts condition. Do these get hats or no? They do. Because all of the information, no, Q, that they gave us are sample information. Whew. It's hard to talk while you're writing those out. Okay. And then our numbers. And feel free to just pause it and do this yourself, and then let mine play out and just check yours. But again, you want to really make sure that it can be read. So take your time. Okay, so those are your conditions. So now we get to the fun stuff. So statistic plus or minus, critical value times standard deviation. Statistic is going to be p hat 1 minus p hat 2, and I've already defined that I'm going to do teens minus adults. Z star, standard deviation, these have hats. 1 over n1, 2 over n2. Okay, let's see. This is 0.63 minus 0.68 plus or minus. I got to go find my critical value. 90%. So 10%, so 5% over here. So inverse norm 0.0501. Z star equals 1.645. So 1.645, boom. 0.63, so this would be 0.37 over that sample size, and then this one was 0.68. And if you'll notice, it's got adults going on the internet daily more often than teens, which is interesting. Okay, The answer for your interval is negative 0.0824, comma negative 0.0176. So that's your interval. Please pause this and type that sucker in because that's a beast. And make sure that you are getting the correct numbers. And then once you're good, just hit play again. All right, well, let's talk about why the fact this interval is negative. Okay, well, remember, we're doing teens minus adults. And if you'll look, it was 63% and 68%. So we're doing small minus big. So our interval for the true difference of proportions should be negative because adults is bigger and it's coming second. Okay, so we're ready for our sentence. I'm going to read it first. We are 90% confident that our interval, that to that, captures the true difference, parentheses, teens minus adults, in the proportion of teens and adults who get on the internet every day. We are 90% confident that our interval captures the true mean, no, not mean, sorry, the true difference, and that difference is teens minus adults. Oh, I can't write. Teens minus adults in the proportion of teens and adults who go on the internet daily. Well, every day, just to use their language. Okay, there's no data statistically significant because, again, we have no H sub O and H sub A. We're not doing a test. We are doing an interval. So we are 90% confident that that interval captures the true difference of teens minus adults, the true difference of the population of all teens minus all adults proportions who get on the internet every day, that it should fall in between that window. So a small difference, I mean, that's a difference of like 8% to 1% that adults are gonna go on more often than teens. So it's a small difference, but it is a difference. All right, then the last thing, your calculator can totally do this for you. But again, remember, you'll see my note at the bottom, no naked math, but it is a great way to check your interval. If you go to stats, you go over to test. If you go to proportion Z interval, make sure you look for interval and not test. And type in all your information. The calculator gives you this as your answer, and this was our interval. So this is the calculator, and this was us by hand. So you can see it was pretty darn close. It's a great way to, again, a great way to check your answer. But a lot of times people just forget about it and don't mess with it, which is fine. I mean, have faith in your stuff. But if you have extra time at the end of something, feel free to check it. Okay, so I hope this has been beneficial. Use this, rewind, watch it again, go to a specific part you need to see again. Just do what you need to do so that you're comfortable with this. The homework on this, it doesn't have tons of problems because once you can do one of these, you should be pretty solid. So the homework shouldn't take you that long, but make sure you do it and check your answers online. And if you have questions, come see me during Smart Breakfast.